So this problem is following directly on the heels of the work we did yesterday. And this is one of the tougher sides. So it's going to lead us through the entire process all the way through. First step, though, it's always the same. It's get the square root by itself. So in this case, that's adding the 4 to both sides of the equation first. We do that so that we can get the square root by itself, because then I can get rid of the square root. So that means I'm going to need to square both sides of my equation. Now when I do that here, on the left side it's fairly easy, because squaring a square root just gets rid of the square root. It'll be x plus 6. But on the right side, when I do x plus 4 squared, remember that's not x squared plus 16. Because x plus 4 squared is really x plus 4 times itself. So we actually have to multiply that whole thing out there. So it's actually x squared plus 8x plus 16. Now at this point, we have a quadratic, because we got that x squared sitting in there. Notice I can't use square root principle because I can't just take the square root of both sides of the equation. The x's are getting in the way with the x squared also in there. So this is one where you have to set the whole thing equal to 0 in order to be able to solve our quadratic. And then we hope that after having done that, we can factor it so we don't have to use quadratic formula. So, is this one factorable? Yeah, because we're looking for two numbers that add to 7 and multiply to 10. And yes, there are two such numbers. It's got to be 5 and 2. So, we end up with x plus 5 times x plus 2, which then we solve through from there. And now that we have our factored form, we can go ahead and then solve it. We can figure out what x equals at this point. So you end up finding that x equals a negative 5 and a negative 2. Now, yesterday we saw there was a new twist involved with this, though. Because we saw that in order to then know what our solutions are, we have to check these. Remember how we can tell if we got to check it? I'm looking for the x inside and outside. Because I have the x inside and outside of the radical, that's what tells me I have to check it. Now, yesterday we saw there was the negative number that was the extraneous solution. Well, in this case, they're both negative. Can we then assume that they're both going to be extraneous? No. We actually have to plug it in. We actually have to see what's going on. So when checking it, remember that you're going to be plugging the number, one number at a time, into the original equation. It has to be into the original. So for instance, I'm going to start by checking the negative 5. So I take the negative 5 and I plug it in for x wherever x appeared in there. And then at this point, we are doing arithmetic. We're not doing algebra, we're doing arithmetic. So you're just following the order of operations. So we do the stuff inside the square root, take the square root, do the subtraction. Notice all we did was just simplify the stuff on the left-hand side. We didn't move stuff to the other side. That could cause us to get that false positive again. We don't want that. And so when we work it all through, we end up finding negative 3 equals negative 5, which definitely is not true. And so the negative 5 then is ruled out as a possible solution. Okay? Knowing that, we now need to check the negative 2. And we don't know anything about the negative 2 yet. It's entirely possible that they're both extraneous. It's also possible that we got one of each. So I plug the negative 2 into the original equation, just like I did with the negative 5. Plug it in for x wherever x appears. And as we simplify that down, doing the arithmetic, just by order of operations, we end up finding that we got negative 2 equals negative 2. That one works. So then, in the end on this, we end up with just x equals negative 2. And that's it. That's our final answer. X just equals negative 2.